Well, we have question 2 here. Question 2.1 says, given the arithmetic series, A plus 13 plus B plus 27, and then question 2.1.1 says, show that A equal to 6 and B equal to 20. I'm gonna write the question here, 2.1.1. I want to prove that A equal to 6 and that B equal to 20. All right, we have given this arithmetic series. It's like A plus 13 plus B plus 27 plus 83. Okay, if it is an arithmetic sequence or arithmetic series, I mean, it means that it has a constant difference D. Okay, so we can work out D by showing that the first difference is common. So we can say 13 minus A equal to B minus 13, and that's equal to 27 minus B. Okay, so the first difference is constant, so it's common. I prefer to take the last two, this one and that one, so I can equate them. Okay, meaning B minus 13, B minus 13 is equal to 27 minus B. Okay, so we can move, I can move the negative B over this side and negative 13 on the other side, and then we will have like B plus B equal to 27. Negative 13 moved over becomes positive 13, and then B plus B makes 2B equal to 27 plus 13. This is equal to 40. And then if we divide by 2 both sides, we divide by 2, we get B equal to 20. So this is proven. Okay. Now that we got B, we can substitute that into any of these. Okay, over here or there. I'm gonna take this one because we also have like 13 minus A equal to B minus 13. So that makes 13 minus A equal to B is 20. So I sub in the values of B, which is 20. 20 minus 13. Okay. Now we're going to work out this, simplify. So 13 minus A is just keep it 13 minus A. 20 minus 13, this is equal to 7. Okay. So if I move the 7 over and move the A over, so it's going to be 13 minus 7 equal to positive A. And then this is 6 equal A, or A equal to 6. Okay. Now proven. Okay. Quote error demonstrandum, to say that it's Latin, it means what was supposed to be proven. Thank you. Now we can do question 2.1.2. The question says, calculate the sum of the first 20 terms of the series. All right, I'm gonna move my board over here. Uh, 2.1.2. Okay, we need the first the sum of the first 20. So we're looking for S20. So what do we know about the sum of the series, arithmetic series? There are two formulas. Okay, one is Sn equal to, n over 2, open square bracket, 2a minus n minus 1 times d. Okay, I'll move it slowly. Times d, and then close the square brackets, or you can also use Sn equal to n over 2, open brackets, L plus A, or A plus L. Let's just, doesn't matter, but I prefer to say A plus L. Okay. Okay, now, what the difference between the two? This is useful when the last term is given, okay? Useful when the last term, use when the last term is given. But this one is to use in any case, okay? Now, because the last term is not given, and we're going to use the first formula. Now, we did find A in the previous video. We did, not in the previous video, but in the previous question, we found that A was equal to 6, okay? And then if A is equal to 6, then we can also determine the constant difference, okay? If A is 6, we have 6 there for A, and it can be 13 minus 6, which is equal to 7. Now, we can do the calculations here. SN will be equal to, or let's just work out S20. S20 will be equal to 20 over n over 2. Sn is like n over 2, 2a minus n minus 1 times d. Okay, so I'm going to substitute, like we have like n is 20, so S20 equal to n over 2, 20 over 2, open square bracket 2a, a is 6 minus n, which is 20, times d is 7. Okay, we can use a calculator for that. Or maybe let's simplify further. So this will be like S20 will be equal to 10, open square brackets, 2 times 6 is 12, okay, minus 19 times 7. Okay, now we can use our calculator. So we have like 10, open bracket, 12 minus 19 times 7. Okay, and excuse me. And this is equal to I think the formula is not, it's plus over here, okay? Because the answer cannot be negative here, it's positive. So now it's, so I need to correct here. I'll put a positive sign, okay? I say the answer cannot be positive, I'll explain why. Okay, the answer is 1450. So S20 equal to 1450. So the answer cannot be negative, because when you look at the question already, we can see that the series is increasing, okay? A is 6, and then 13, and then B is 20, 27. If it is increasing, the sum cannot be negative, okay? The sum must be positive, because we know the value of A here is now 6, B is now 20, and then at 27, etc. So the answer must be positive. So S20 equal to 1450. Excuse me. Now, question 2.1.3 says write the series in question 2.1.2 in sigma notation. All right. So I'm now gonna move this over here. 2.1.2.3 now. We want to write the series of 2.1.2 in sigma notation. All right. Sigma notation is this notation. So now the sigma notation is given by sigma, and then in the brackets here we're going to press in Tn, okay? And then n starting from 1 to the number starts from 1 to n. So if I need to write the series, I'm going to say I need to first find Tn. Tn Tn is given by, in its turn, is given by A plus n minus 1 times d. So we do know A, the first value. Tn will be, A is the first value, is it was calculated was 6, and then the constant difference also was found is 7. Okay, so we have like 6 plus n minus 1 times 7. So Tn will be equal to 6 plus 7n minus 7, and Tn equal to 7n minus 1. So this is Tn. Therefore, the sigma notation wouldn't be excuse me, 7n minus 1. N starting from 1 to 20. So this will be the sigma notation of this sum. So I can write it like, let me write it here. S20 will be equal to the sum of 7n minus 1 in the bracket, n starting from 1 to 20. Yes. And this was found to be 1450. Okay. Well, thank you.